So for problem number 2, 250 by 23 channels are welded together as shown in the figure. Okay, so we have here one C channel rotated 90 degrees, and we have here the one C channel, standing C channel. We have to determine the location of the centroid, okay, location of the centroid, and determine its moment of inertia, section modulus, and radius of gyration with respect to its centroidal axis. Okay, so the properties of C25 by 23 is given here. So the area is 2880 mm squared, Ix is 27.8 raised to 6, Iy is equal to 0.922 raised to 6, and X is equal to 15.9. Okay, so these given properties of C channels is in this particular manner. Naka-standing C section tayo. Okay, so we have to solve for the location of the centroid. So depth of C 250 by 23 is 254 mm. Okay, so this is 254 mm. And the thickness of the web of the C channel TW is equal to 6.1. Okay, so the whole depth of our whole section is equal to 254 plus 6.1, that is 260.1. Okay, our X is 15.9. So from here up to this centroid of the rotated C channel, that is 15.9. Okay, and so our distance here is 2880 times 260.1 from the bottom minus 15.9. Okay, that is the distance plus the standing C section. We have 2880, that is the area, times the distance. Okay, so the distance from the bottom, okay, so that is 254. Half of 254 is 127, so we have here the centroid of the standing C channel. Okay, so distance from the bottom is equal to 127, so multiplied by 127. Okay, solving for the equation, y bar now is equal to 185.6 mm. Okay, so I have here now my location of centroid from the bottom. Okay, if you take your distance from the top, the value will be different. Okay, so if you take your location from the top, your y bar should be equal to 74.5. Okay, so we have now the location of centroid. We can now solve for the moment of inertia with respect to its centroidal axis. Okay, so for Ix, for the standing, so we have the Ix of the standing C section, that is given 27.8 times 10 raised to 6 plus, since our centroid of the C standing does not coincide with the centroid of the whole section, we need to transfer. Okay, so gagamit tayo ng transfer formula, that is area times d squared, the location, distance of the location of 2 between the two centroids. Okay, so we have area 2880, distance. Ano yung distance natin? This is our y bar. Okay, so our XO-axis for the whole section is located 185.6 mm from the bottom. Okay, and in our C standing, yung C section natin, to, ang location natin ng centroid from the bottom is equal to 127. So we have that, 127. Okay? We need the distances between the centroid. So centroid of the C section from the centroid of the whole section is this value. Okay, so what is now that D? Okay, so that is 185.6 minus 127 squared. Okay, that is for the C channel standing. How about the C channel that is rotated? How about the rotated C channel? Minus 58.6. Okay. So for the rotated C channel, okay, so we have that plus our moment of inertia, that is 0.922 times 10 raised to 6 plus the area. So area 2880 times that distance. This is the distance of the centroid of the rotated C channel from our whole section, centroid of the whole section. So that is, okay, so if this is 74.5 from the top, and that is 15.9, so we have the distance here is 74.5 minus 15.9 squared. Okay? So solving for our equation, our Ix now is equal to 48.50 times 10 raised to 6 mm to the 4. Okay? How about our Iy? Iy. Okay? Iy. Iy, given the properties of C20, that is 27.8 times 10 raised to 6. This is for the rotated. And for the C standing, plus 0.922 times 10 raised to 6. That is our Iy. We don't need to transfer our moment of inertia since the centroid is located or coincides with the centroid of the whole section. So that is equal to 28.72 times 10 raised to 6 mm to the 4. Okay, so this will be now our Iy. Okay, solving for our section modulus, Sx. Okay, Sx is equal to Ix over C. Ix is given, that is 48.50 times 10 raised to 6. How about our C? Okay, C is the farthest distance from the top or the bottom fiber of our section from our centroid. Okay, so yung C natin, yung pinakamalayong distance doon sa ating centroid. Okay? So, 74.5 sa taas and 185.6 sa baba. So, yung magiging C natin dito is 185.6. Okay? Times 10, 6 over 185.6. So, our Sx now is equal to 261.314 times 10 raised to 3 mm to the cube. Okay, for SY, that is IY over C. IY is computed. That is equal to 28.72 raised to 6 times 10 raised to 6. And our C, what is our C? Okay, so that is 254. The whole depth, that is 254. Okay, half of 254, since our YO is here, that is 127. So C is 127. So that is 28.72 times 10 raised to 6 over 127. Okay? So value here is 226.16 times 10 raised to 3 mm to the cube. Okay? That is for the section modulus with respect to x and y centroidal axis. How about for the Rx? Rx, that is equal to the square root of Ix over A. Okay? A is the total area. So we have 2880 times 2. Okay? Substituting the values, 48.5 times 10 raised to 6 times 2880 times 2. That is the total area of the whole section. Our Rx now is equal to 91.76 mm. Okay? And Ry is equal to the square root of Iy over A. That is the total section. Substituting Iy is 28.72 raised to 6. Our area is 2880 times 2. Our value now for Ry is 70.61 mm. Okay? So we have here value for Ix, Iy, Sx, Sy, Rx, and Ry. This is Iy. Okay? So that is for problem number 2.